And welcome back to Rear Build Series, episode 153. So, going to be doing some building on this one. I wasn't really all that keen on doing some building on screen, but think we'll go ahead and do that. So what I did here so far is I've grabbed the Katie's Autopilot microcontroller, and I'm getting ready to port it in. So I thought some people might find this interesting. So first I wasn't going to do it, then I kind of decided, some people might be interested. So currently kind of working through it and hooking it up to what I already have here. And so I need to add in some new equipment, so I'm going to just kind of do this as I go. So I'm going to do roll tilt. I should have all this stuff for Sky's PFD. That tends to have most of the stuff, which is convenient that I don't have to duplicate it. Let's see, should need compass on this, so just plugging all this in because this is a helicopter's autopilot, of course, so I do have to change it a little bit, but hopefully I don't have to do too much. There are a couple things that are going to be different because of the way I have this already set up. So, okay, so here are some tilt sensors here. Let me start to figure these out. So this is the roll tilt right here. Is it? No, it isn't. This is roll tilt right here, so hook that up. There we at here, roll tilt. Pitch tilt, roll tilt. All right, pitch tilt is going to be the one facing forward, so I need to kind of find that. And so I'll find it off of Sky's PFD here. Tilt sensor up. Pitch sensor looking front. So right there, that's this one, and we'll grab that. So there's tilt sensor pitch. That is compass, so I can go to the compass. And I'll just port all this in. Desired altitude is going to go here to this keypad. All right, and so let's angular speed yaw. So I should have an angular speed here somewhere. Speed sensor vertical. Let's see. Angular speed sensor is close to center of mass. So that's what I want. That's not plugged in, so I kind of need that. Where's CFG? Right there. All right, so here's an angular speed sensor. All right, and I don't know. I thought I had one, but maybe I didn't. All right, so I kind of have to be careful here, make sure I don't delete anything I need. So I'm going to kind of go up here, and I think I can delete right here. And that should be good, yeah. And so this can go there. And so I did miss that earlier. All right. Let's merge that in there and hook that up to both places it needs to go. So that goes here. And this should be the yaw. This isn't very important because this isn't a helicopter, but this build. But what am I missing here? I think most of this is plugged in. That is vertical speed. So I have vertical speed here. Should be. I think he has it labeled as speed. Looking up, pitch sensor looking forward, angular speed, temp probe. Where is it? Vertical speed. Okay, right there. Okay, vertical speed's right here. All right, and with that, that's roll. All right, so I have to kind of port some of these things in. Like yaw's fine. Roll is different, and the reason roll is different is because I'm using flaperon. So I'm adding to it to have flaperon. So we have roll comes in from the gyro, and it comes into this box, and then it splits to the other two. So what I need to do is I need to take roll here, and I need to go to the roll on here. That comes from the seat. So what I'm doing is I'm just essentially, is it coming from the seat? It should be coming from the seat. Let me double check. Yeah, roll is coming from the seat. So now roll is going to come from this panel. So essentially the seat's feeding through this panel, and then it's going out. And so that will work. That way, the seat will come up into the panel will go down the gyro will go in here, and it will then control the ailerons and the flaperons properly. I need that to function properly. And then that's pitch. So pitch should be able to go out. What is this? Autopilot pitch fins. What is that? Oh, okay, see, these are the fins. The fins I need. Because there's a helicopter microcontroller, I have some things that I don't need. So the good thing about that is I can start to get rid of some stuff that I don't need. So for example, roll needs to stay. Vertical speed, yaw fin, pitch fin. I labeled them fin because of I use both fins and the actual rotors. So pitch, goes to the rotor. Pitch tilt is good. Collective can go. Okay, so that cleans us up a little bit. I didn't want to get the microcontroller yet. All right, so I want to make sure this is all connected before I start screwing around. All right, because I have to go in there and then I have to change this up so that it functions more as a plane. Let me see how much I can delete here before. See, I don't have much underneath that I can. Actually, you know what? This is the end of the wings. I could go in there. So I need to move things around now to kind of see where I need to be. So let's go in there and look. So I can shrink it this direction. So let me just shrink the panel up. I'm not going to shrink it yet. It sometimes breaks the connections. It does. So seat. This is bearing microcontroller, and we need this because if you remember, this will, essentially send us to the bearing we put. And I'm going to just check my other ones. Gyro needs to go through here. One of the reasons I was having issues flying the Cormorant with the gyro was it was on my seat. It wasn't actually on the panel, so I kept trying to turn it on with the panel. It wasn't working. Vertical speed, where are you at? That was, I found it, and that got disconnected. When you move those nodes, you often break them. So, vertical speed sensor is there. Okay. So just rehooking those up. If I could find it again, there it is, right there. Okay, good. So that's good. So now let's get into the actual panel and see what's up. So this is designed to function with a helicopter. So a bunch of that stuff I've just deleted out. We won't really need much of it here. I don't think we really need to change all that much, surprisingly, because of the way it functions. So station keeping we don't need at all. But there's no point in me really getting rid of it. It just, again, don't need it, but station keeping is not something I need. I could just leave it in there as long as the channels don't interact in a bad way. Like what I can do is I can disconnect that PID and then I don't have to worry about it any longer. I could actually, you know what I'll do? I'll redo that and then I'll just disconnect this add here and I'll go right to there. Come on, give me and let me delete it. Thank you. So that right there fixes that issue with the station keeping. Don't need that. I'll eventually delete it, but I'm not really in a huge rush. So the fins are going to be different because the helicopter, the fins need to work over a certain speed. So kind of looking through this, trying to figure everything out. So let's go kind of do this methodically, and I'll go through control surface by control surface. So first we have our roll. So our roll is channel 1. That is AD, that is correct. So we want to add AD to whatever the autopilot wants us to do. And so that is already set in here. That should work as a roll autopilot. So that should be done, I hope. Let's see. Yaw fin, yaw is right here. let's see. So this is angular speed yaw. So this is mainly keeping our yaw steady. That's fine. We can keep that. We don't really need it. Helicopter, it's, you know, we need it to counteract the torque of the rotor. Really don't need it to do anything on, you know, on the plane, but it's not going to hurt us. And then that is being added to, what's that being added to? So I'm trying to find, so this right here, 3 is going to be AD, that's, I'm sorry, left, right, that's right there. This is our yaw control there, and then we add it to our ability to run it with that. This is taking angular speed and steadying the yaw, and then all that's coming together to do yaw. So that's good, that's done. So it looks like roll is done, yaw is done. So that's good. Last we have is pitch. So I need to figure pitch. All that's just compass stuff. And I need to find pitch. So roll. All right. So here's pitch fin right here. So this is our pitch area. Let's see. So I have 2, which is WS. That's added to this function, all this PID business here, which is our is going to control our pitch fins. And as you can see here, I have a vertical speed. So essentially, I'm setting in the vertical speed I want, and it's coming in and it's going through 2 PIDs. So that should hopefully work. Now what I need to do is trying to keep a steady method with this is, so the bearing micro, I need to go through and I need to check the numbers because the numbers are possibly going to be a mess. And so I need to correct the numbers, let's put it that way. So we have the seat, channel 4. What do we got? 1, 2, so 4 is up, down. Up, down is collective. As you can see, this is attached to nothing because I don't have collective. And so I don't need to worry about that. So like this here is our desired altitude. This is going for collective. And then, so I need to find my, so where are my pitch fins here? So all that could be deleted, but I'm not in a huge rush to do it. You know, it won't interfere with anything, and if I delete something that I need, I'm going to cause problems. So right here is pitch fins, that's what I need. And that appears to be connected and working because we have desired altitude there. This is our current altitude, that gives us that. So I think we're getting reasonably close to testing this. So what I need to do is I need to check out the Autopilot panel and make sure that's all set up for this. So I have seat. I have, what's this? This is bearing microcontroller right here. I'm trying to see where is my Autopilot panel is the question. So bearing microcontroller 1, numerical switch box, desired heading. Okay, so this is either going to do the desired heading or this is going to allow me to use the bearing microcontroller. So that's fine. I need to check this number, so let's update this. Let's go in and check that. So trying to do one thing at a time and then kind of, you know, back it up if I need to. So 2 is 1, that works. So the number is, or the 2 position, 1 that works, that's what this is. So that reads channel 1. That will switch us to either using the bearing, have it auto follow the bearing, or use the what I enter in the keypad. So that should be all set up. I need to hook in the Autopilot system. So right here, bearing micro 9. I think the Autopilot panel is supposed to talk to the bearing microcontroller. Let me look. So if it does that, the panel essentially goes through. So right here we have, let me look at the panel really quick. So we have panel in. So panel in is going to be my Autopilot panel, I believe. So that's bearing micro out. That is panel. No, that's fine. Okay, so let me do this. Let me save this as Cormorant Autopilot, and I need to see on Katie how I connected this up just to speed things up. All right, so I have my Autopilot panel here. My Autopilot panel. Then I need to see how it interacts with my Autopilot. So, because this is my Autopilot master right here, and I need to figure this out. So this goes over here. And then where does this reconnect to my... So let's see what the number is. So AP master is 13. Where is station keeping on this? Is this the latest version of Katie? This seems very strange to me. No, this is a super old version of Katie. What is this? What is going on here? That's an old spelling, I think. Yeah, that was an old build. That's ugly. Okay, so this is the one I want. So this goes to bearing panel. So it's from this Autopilot panel goes here. The bearing panel goes to Autopilot and then into there. Okay, so that's better. Okay, so that's good to know. All right, so I pulled up a really old version of Katie did. Okay, so I did it again. I didn't mean to do that. Cormorant Autopilot work. Okay, so let's. So bearing panel needs to talk to the Autopilot panel. So that's fine. So this will go right here. We'll go there. This will go. That talks to that. This talks to that. This will go up here to panel. And then that should all communicate now. So I need to check my numbers now. So this is 1. This should be, that's fine if it's 7, but that's going to be AP master. I'm changing up the way I do this too. So 1 is going to be AP master. Let's just make it 2. AP master. Let me not screw with stuff too much. Let me check where it's going. I need to make sure that this isn't going anywhere weird first. Okay, it isn't. Okay, good. So this is going to be 2. All right, then I want to do stabilizer. That's essentially the gyro. I'll just call it gyro. Gyro. And this is going to be a button. Normally I do it when I do the Autopilot Master, but the Autopilot Master's job is supposed to be that when you shut that button off, it shuts all the Autopilot systems off. And so that's important because, you know, in emergency, you want to be able to quickly click your Autopilot off and have everything shut off. You want your heading hold off. You want your bearing hold off. You want your altitude hold off. You want all that stuff off because, you know, in emergency, you want to be able to take over quickly, press one button, kill it all, and then go. And then the other button, gyro. So when the AP master's on, the gyro will automatically come on. But if I want the gyro to be on without the Autopilot master, I can also select the gyro. So this will be 3. Be a button, a toggle, and it'll be 3. All right, so that's good. All right, so let's keep moving here. All right, so let's go back in here, and then I need to find where I'm at here. So bearing micro out. This is doing the. This is the master right here. Is 9. So what's doing the function of this is 9. That's going to be now be 2. So 2 is going to do the, so 2 is going to be the master for all of those. So without that on, none of the systems are going to work. So it's like a hot shut off. It kills everything. And that's important for safety reasons, to be able to just shut everything down. I want control. And that really makes it so that you can, in emergency, take over and not have issues. So that's good. That's numbered up correctly. It is. All right. And then gyro. This is going out to the gyro somewhere. I need to find it. It's an output. What is this constant on signal here? Okay, this angular speed is constantly on because of yeah, this angular speed is constantly on because of that. I don't need any of this. Let's get rid of it. This is a helicopter thing. I don't need it. And so we'll just go like that. Yeah, I don't need that because that's just a relic of being a helicopter. I don't need the rudder giving me erroneous inputs that are going to potentially cause me massive problems. So I'll get rid of it. And then that is angular yaw. That can go. All right, so that's gone. And then we'll continue here and see where we can get. So I need to find the gyro, where it turns the gyro on. So it should be a red output. And then that's going to turn my gyro on or off. And I think it goes through this panel. I'll have to double check. I'm not seeing it at the moment. So it should be connected to this node here. Here it is, gyro right here. Okay, so if this is on, and what else? All right, so essentially in the helicopter, I'm shutting off my gyro if I go over a certain speed. I don't really want that in the airplane. So right there it goes, if linear speed is not greater than 30, and the button is on gyro. So I don't want all this. I just want if, and I want gyro to be an or. So let me actually take that. No, I don't want an and, I want an or. So this will allow me to either use my gyro button to turn on the gyro or AP master. So AP master is going to do it, and then if we remember 3 is going to be our gyro only button. And then that will go like that, and that will also turn on the gyro so that we have gyro. And only when we want it. So that works out. So let's try this. Let's quickly look at everything, make sure everything looks cool. Check electricities. See, this panel doesn't have electricity. What is this? Why does this not have electricity? That is weird. That doesn't have electricity. Okay. Nope, I didn't mean to do that. Okay, so that's back connected again. Okay, so that's all connected up properly. Glad I checked. This, like, see, this stuff, I hadn't used this yet, so I hadn't bothered to connect any of this, so that needed to be all connected. All right, so this hopefully should be good. Oh, somebody noticed in one of my videos this this HUD is backwards, or this HUD is inverted, and so that should fix that. Just did the inversion. That's because I use symmetry. Panel stuff, you shouldn't really use symmetry. All right, so that's good. Let's go take this for a little run. I should be able to test most of it in the hangar. So we're on the test world here. And let's test it all out. And I would be shocked if it all works on the first try. And so part of it was a little bit complex because I had to go through, you know, all the specialized stuff that I have on here. All right, so first thing we'll do is let's look, make sure we can manually control everything. That's most important. So roll is correct. Pitch is correct. This is always the most important thing. Can I take over in an emergency? And the answer is yes. I don't know why those, see these fins here? Those fins should not be doing anything if I'm not in the water. So I need to look into those. So I'm going to write that down. Those are not supposed to be functioning unless it's the water detectors, the fluid detectors are, if I could speak, that'd be great. If the fluid meters are not detecting water, those should not be doing anything, and so they are working. So I need to screw with those. So let's check water fins moving out of water. Okay. All right, so let's go back to what I was doing here. Roll, pitch, yaw works. Okay, so that's the most important thing. Next, I want to put in a heading hold. What are we currently at? 132, so we'll do 180. That should give us aileron for roll right, and that should also give us rudder for yaw right. When I click AP Master on, we have yaw right. Have nothing. Maybe we do. I have to go check. You don't want too much roll. It's setting the roll to a certain amount. I want to check and see. So we do have some roll in there. We'll have to see how it functions in the air, but I would think because it's not actually achieving it, it would just keep ramping up. All right, so that's good. We're going to do the opposite, 360 for north. And we have yaw left, and then I'm going to check those ailerons again. If they're still at the same value, they're not doing anything. So this was like negative something. Yeah, see, it's at the same value. So my roll, something's funky with my roll. I need to check, but I will. All right, so that's good for the yaw at least. Pitch. So let's go ahead. Let's set an altitude of 1,000, and let's check. Perfect. So that's trying to pitch the tail down, which pitches the nose up, which allows us to climb. Let's go negative 1,000. And that should be the opposite. Let's do altitude. I'm just putting things on my list. Altitude, hold, backlight. All right. Altitude, hold, backlight is not working. And let's check it. As you can see, the elevators are pointed the opposite direction. So those are working. All right, so roll we need to work on. I'm going to start a whole new AP category here on the on my drive. I'm kind of doing that off screen. All right, and I will put in a checkbox for that. All right, so I need to fix roll. And what we'll do is we'll take it for a little flight anyways. Anyway. I don't think I've ever said anyways in my life, and then I just did it because somebody said it on one of my podcasts. All right, brake, there we go. Flap it up. All right, yeah, so I needed to, I have to port things over because, this, with the flapper-ons, I go through a different panel. So it's going from panel to panel to panel. Oh, so this is it again, as my trim is screwing up my... If the trim's not 0, I can't use my throttle. Whoa, 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 what are you doing? Oh, Autopilot Master. Shut up, AP Master. What is it doing, man? Why is it on its nose? I don't get that. Oh, parking brake. I have the parking brake on. That's why I was like, what is it doing? Parking brake. It was a me. It was a me problem again. So I'm just gonna... Oh, come on, come on, come on. Get in the air, get in the air, get in the air, get in the air, get in the air. Get in the air. I don't want to hit trees. Alright, that sucks, dude. That just wastes time. Let me fix the roll before I even bother. It's going to be a waste of time if I don't do that first. So probably what's happening is the way I ported this system in. So let's kind of follow the path. You can see the path with it. So I go from the seat up to the autopilot box. Okay. So then so from right here, roll is AD. So we go from our seat to AD, which would be 1, which is right here. All right, so that is added. So that's working. What's not working is the autopilot section. And so I'm going to go through here and try to fix it. So, okay, so this is the issue here, I think. Again, when I was running this as a helicopter, it was causing it so that Yeah, so this is all stuff for a helicopter. All right, so this PID here can go. All right, so this essentially what this does is it makes my fins not work at a certain under a certain speed. I don't want that anymore. So this whole section can go here. Again, you know, kind of file this under legacy code, and that's why it's not working well. What is 4? Did I screw myself up here? What is 4? 4 is yaw. Okay, so 4 goes there. Make sure I have 4 down here as well. 3. No, 4 is up down. 4 is collective. I don't need 4. Okay. All right. Again, I'm converting a helicopter into an airplane. The nice thing is when this is done, I do have other airplane microcontrollers, but this is going to be the kind of my latest up-to-date how I do things. So I don't want to take some of that. Like I want to port this autopilot over to the Frogfoot. All right, so this can go here. So 4 can go. 4 is collective. I don't need that. I have my, that can go, this can go, this can go. Linear speed. Speed is greater than 30. That doesn't matter anymore. That was a helicopter thing that I needed. Okay, let me just get back up a second here. Okay, what is all this crap here? Desired altitude. This is the conversion here. Okay. All right, it clamps it out at, what is that all about? I'm just looking at why it's clamped at 5. That's kind of a silly number. All right, so this is the desired altitude altimeter. So this comes out of the clamp. It goes here. Pitch fin. So this right here is my pitch. That is fine. Did I screw anything up with this that I should not have? Nope, that is fine. So okay, so this is fine. This is essentially giving me pitch, and then this is setting it to a maximum vertical speed. So that's all fine. That goes out to pitch. Pitch is fine. Roll is my issue, so that's fine. And then coming through here, linear speed, I no longer need this. So I'm kind of trying to figure out what's up with this. So this can go. Yeah, that can go. So I'm just kind of trying to be a little bit careful breaking these down. All right, so this here is station keeping. I don't need that, so what I'm going to do is I'm going to start deleting out station keeping. That can go. This is all station keeping here. So what is 2? 2 is WS. So yeah, so this here is yeah, so this here is my pitch for the station keeping, which I no longer need. All right. So I'm just trying to kind of pay attention as I'm doing this, because if I delete something, it's going to be a lot harder to figure it out to fix it. So this can go. That could go. That could go. This is all station keeping up here. So I'm going to just get rid of it. Because, you know, this will not station keep. Because this will just kind of loop around. This will almost do like a hold. Okay, that's going pi r square all the way down here. Compass. So I don't really need... I need the compass for other things, but I don't need it for this. That can go. All of this is station keeping, and that can all go. All right, so that simplifies that a little bit. So let's continue with our roll issues. So I have the seat. The seat is coming across. It's reading channel 1, which is WS, which is adding to this, which then allows me to manually control roll. That's working fine. The issue that we're having is the is over here. And so what I want to do is What is that reading? All right, so essentially what this is doing is this is taking whatever I have for my yaw. It's coming up here and it's clamping it at 0.07. And then that is going, instead of going through this numerical switch box, it's going to go right in here. And so what that does is, in the helicopter, I don't want katydid to roll until we're up to a certain speed. Then it would be realistic. So this should go here instead, because now there's an airplane, it always needs to roll. And that's going to go there. Roll tilt will go there. So this is going to give us, essentially what this is doing is, it's giving me a max roll tilt of negative 0.07 or a positive 0.07 tilt. So essentially setting my bank angle. This sets my bank angle. And then that comes over from the PID, and this will give me my roll component for that. So that was probably that. This here is not what I want. I want to come off of 2, which is my autopilot master, and I want to go there. All right, so a lot of this or business here, that is all stuff that I need for other stuff, for helicopter stuff. So this can all pretty much go. Yeah, see all this confusing stuff? That can pretty much go. That can go. Linear speed can go at some point. I'll put this so that's straightened up. All right, so what is this switch box here? So compass heading. Numerical switch box or. Okay, so this is determining what direction I roll in. All right, so if the, okay, so I don't want that because let me see what I want. This could work. I have to look at it though. Because again, I'm porting it over from a helicopter, so it's a little bit different. I need to think about this. So this could go. All right, so I need to back some stuff up here. I did need some of that. So this section here, I need. Let's see. Okay, so this here I can delete up to there. So if we're reading 2 or that. Okay, so this is good. So these here essentially are, if my heading is a certain, if I need to turn a certain amount to the right, I'm going to roll. If it's like a tiny little bit, I just yaw a little bit. If I have, like say I have to turn 20 degrees to the right, this is going to cause my wings to then roll. I don't want to, because this would cause me to roll constantly, and it would be obnoxious. So all this is annoying, but I'm going to keep it for now, and I might clean it up later at some point. But that's all stuff I need. So let's, I don't know what this crap is over here anymore, but it can go. All right, so let's save this. And so we're going to go back in, and we're going to try to make sure we get a roll when I put in an autopilot heading that is to my left or right. I want the correct corresponding roll. So we want master on. That's all I really need on. All right, so heading hold. Let's head 180. That should be ailerons for a right roll and a rudder to the right when an AP master is on. All right, so see our ailerons are moving now. So we have a right yaw on the rudder. So that's going to cause us to turn right, which 180 is to our right. We want the left wing to go up. So that's going down to give us more lift to put that wing up. And we want this one to go down. So that's all working correctly. If I shut off Autopilot Master, as you can see, they zero out. That's exactly what I want. So, for example, let's say I do that. Let's say I do 1,000 feet. I should have my elevators up. They are. Should have my rudder going to the right. It is. Left aileron down, right aileron going up. All right, and then if I press Autopilot Master and Emergency or whatever, you see they all go away, and now I have ultimate control over everything. All right. So let's go ahead and let's test this out. So I want to start with my gyro on. And I don't know if I can get to my gyro where I can read it. I don't know where it is. It's somewhere in the tail. I want to just make sure that that is correctly turning on the gyro, because I didn't have it on for a long time. I see sometimes I leave it where I can actually access it, but I don't think I did this time. Not a big deal. I should find out when I get in the air. I can definitely figure it out when I get in the air. Oh, come on. Climbing up this gear is a little bit iffy. All right, let's go in here and let's get going. Go do a little test flight. So, master power, engine start, stop. Go full flaps. Set my prop to 30%. Actually, 28.5 is about my max, is my best speed. Release the parking brake this time instead of, you know, scratching my nose. At some point, I'll release my autopilots. I pretty much make a brand new autopilot or port it over to a particular craft for each craft, and it's kind of the right way to do it, just because like each craft behaves so differently. Like, you know, if you have something big and heavy, and I want it to turn slowly, it functions different than if it's light, you know. So I have the gyro on. Alright, so I can definitely tell the gyros. Can I tell the gyros on? Let me check my trims here. I wish there was a 0 trims key. That would be kind of nice. Oh, that can screw me up right there. Okay, so all that is zeroed. I see the gyro should be leveling me, but it's not. Actually, it seems like it's working. It's just, it's not controlling my roll at all. Okay, so I'll put that on my list. Okay, so the gyro is not controlling the roll, so I need to make sure that passes through there properly. That's fine. It's just not doing it. Okay, autopilot's on. Let's go ahead. We have a heading hold of 180 in there. We have an altitude of 1,000 in. And so it should be turning us to 180. It is. We're at 1,000 feet. I was like, oh, we're not climbing. It's because we're already there. So this should roll out. You see it's gently rolling out when we get there. See how it's doing this dance? The reason it's doing that dance is, you know how I was telling you that part of it? That's supposed to fix it. So essentially, when you're within a certain range of the... Okay, part of it was the flaps. The flaps were causing it. The flaps took away some of my roll, my ability to roll, and because I took away some of my ability to roll, it couldn't keep enough precision, and so now with the flaps up, it gives me precision. Let's put the gear up. Alright, so let's do, it's kind of a little iffy on the altitude. It's within 10 feet. Let's go to 2,000 feet. Let's do a couple things at once. We want to try multiple things to make sure that you can kind of overload the autopilot and it does everything you want. So we're climbing and we're turning. So we're going to be turning to a heading of 270, which is west. We're going to be climbing to up to 2,000 feet. All right, so I set my climb rate to about, if I recall, about 1,000 feet per minute. That used to be our normal climb rate in the airlines, was 1,000 feet per minute. It seems slow in game, but you know, it's for comfort. You know, you start putting on G's if you're doing much more than that. Not a lot of G's, but you know, if you're doing like, the most I ever did was about, oh, I don't know, 13,000 feet per minute climb, something like that, 11,000 foot per minute descent. You're piling on G's then, but you know, you're not piling that many G's on. But again, you know, if you have passengers walking around the back, you don't want to be slamming the plane around. Also, if you have an unpressurized airplane, you know, of course there's a game, you don't have to worry about this, but just some info in case anyone's interested is, you know, you think about, like, if you go down a mountain in your car, you even go down a hill in your car and your ears start clogging up and you have to, you know, do the Valsalva and clear your ears. That's because the pressure changes. And so by slowly changing altitude, it allows you, here's the ring of fire, it allows you to, you know, clear your ears more readily. Now, of course, you know, we really don't have to worry about this in game. Let me check this, make sure. Okay, so this isn't working. I have to fix that. So I'll put that on my to-do list here. Let's see. FO, PFD, in op. Okay. So that's first officers, PFDs, and operative, and that will fix that. All right, so let's check the bearing panel, make sure the bearing panel is working. So let's go ahead right to here. I'm curious how this is going to hold. What a hold is, it should circle the waypoint. All right, so next, this should take priority over the heading hold. It does. All right. We're still climbing up to 2,000. I might double that. It's a little bit slow for in-game. With the helicopter, it made sense because I think it was also using the collective. And so the collective was also helping you get up there. So this is going to go to 051. And as you can see, we're slowing down as we get close to it. And because I have the roll tied into the yaw, you see how smoothly it rolls out? It rolls out very naturally to how you do it in real life. So I need a correction factor of about 9 feet in here. So I could put in a correction factor to get that spot on the money. So I'll put that in as well. We'll add a 9-foot correction factor. So that's just me correcting the, essentially correcting the altimeter, which you have to do something similar to that in real life. So what I'm going to do is I'm going to really hammer on the speed here. Actually, we are at full speed. We're going to go ahead and we're going to go up there. So one thing I have to worry about in this plane is I do need to put an over temp protection. So let me put that in there. Let's do a delta over temp protection. So one thing that I've yet to do a delta based over temp protection, and so all that would be so I don't know how it's going to work yet. Let me quickly, if I go down to 700, I think I don't gain any temp. So I'm just going to keep reducing my throttle till I get no more rise in temp. So 840. So let's say 800 we'll lose temp probably. So let's go down to 800 RPM. Okay, so that's about 800 RPM. You see we're losing temp. So let's do a, let's see, 800 RPM loses temp. All right, so there's a couple ways to do this. The quick and easy way is, you essentially put a numerical switch box, and you set a condition something towards the effect of if temp is, essentially if the temperature is greater than 100 degrees, you essentially put a limiter on, you put a clamp on your RPM so that it can only go to 800. And we know that at 800 we can't overheat because we actually lose heat, and that's all you do. So this is dancing a little bit. That's fine. As we get closer and closer to a waypoint, you have to move more and more to correct. So that's all it's doing. That's why it's jiggling like that. Is it's trying to make tiny, tiny, minute corrections. Now let's see if it puts itself in a hold. All right, so this should put itself in a hold. And a hold is, you might have flown a hold in an airliner where you essentially, do kind of like a racetrack pattern. And it keeps you over a certain area. And so like say that often what would happen is if you have bad weather, normally you would land one plane every minute. Well, if you had some bad weather, they would increase separation and they would make it so that you land one plane every 2 minutes. So as you can imagine, you're getting half the planes, and so what you would do is the planes would start stacking up, and so you'd put a bunch of planes in the hold to give them time to get the planes in. And so you'd put a couple in this racetrack pattern in the sky, and they'd even stack us. Like sometimes they'd stack us 10 above, 1,000 feet each. And you could see the planes all holding, and then when it was your turn, they'd call you in, and you'd leave the hold, and you'd come down. So this is doing a beautiful hold. See how it's doing a nice circle around the waypoint? That's what I want. So essentially, let's say I set the autopilot to go somewhere and I go AFK. When I come back, it should just be circling over the waypoint. Now, of course, the helicopter, I want it to go and actually stop and sit there right? But this, it's a plane. I don't want it stopping. I want it to keep moving. And so what you'd actually do in the hold too in real life is you'd slow down. So think of it this way, right? You try to take your car around, a corner, right? If you're going too fast, right, you can't make a really tight corner. I need to bring up my throttle. I'm going to crash here. Okay. Okay, there we go. I'm just trying to slow down here. So think about it. You come up to a 90-degree corner, right? You have to slow down to make that turn, right? Because your car is going to, there's going to be so much centrifugal motion that it's going to cause your car to kind of go way out and do too much, right? So the slower you go, right, the tighter of the circle you can get. And the same thing is true with an airplane. So if you slow down, your circle will be smaller. And so this actually was kind of funny. This happened going into Boston one day. We entered the hold, so our policy was slow down at 200 knots, so we'd have to drop a notch of flaps, slow down at 200, enter the hold. And so at 200, your circle is a reasonable size. Well, the JetBlue 1,000 feet above us forgot to slow down. They were going 320 knots. So their circle was enormous. And so ATC is like, JetBlue, are you ever going to slow down? You're taking up half my sky because, they forgot to slow down. And so, they just, once they slowed down, their circle decreased in size because, they were going a lot slower. All right, so this is working beautifully. We have a nice hold, so I could go AFK, and this will automatically hold. I won't crash unless I run out of fuel. So this is working really beautifully. Let's give it some more stress testing here. So what I'm going to do is I'm going to set 090, and I want to go down to 200 feet. So this could be dicey. So this, and the reason I say this is dicey is I don't think it's going to be a big deal because I have that vertical speed limiter on there. It's going to make it so that I don't descend too fast, but you have to be careful to make sure that it captures the altitude before it shoots through and hits the water. And so we're coming out on 090 now, so we should be leveling out here right now beautifully. So yeah, definitely tying that into the yaw is awesome because that really makes for smooth aileron motion. You notice a lot of people is they, once it hits the heading, it jerks to center, and that would be pretty miserable in real life doing that all day. Doing kind of like a fighter jets. If you're in a fighter jet, that's kind of how they do it, but not if you're in a regular, passenger plane. All right, so at this vertical speed, this should capture fine. I don't know if I even want to increase the vertical speed. You know what I might do? I might make a maximum climb vertical speed a little bit higher and then a slower descent. I don't know. So let's see if this captures 200. Beautiful. And as you can see, we're about consistently about 10 feet. We're about 10 feet low. That's part of that's the PID. To tune the PID in so it's not too wiggly, you have to give it some allowance. And so currently the allowance is like about, I'll say 11 feet because it's been either 10 to 12 feet off. So you could try to tune the PID, but then you're going to lose some of that effectiveness. The better way to do it, I find, is put in a correction value. So let's go ahead and do that. The autopilot's working really well. That actually didn't take all that long to port. And that was taking a helicopter's autopilot and converting it to be a plane's autopilot. So that's actually pretty good. What was I just doing? Okay, so roll. Let's. Okay, correction factor. Let's put in a correction factor. And so what we want to do here is let's look at this. So right here, it takes the altimeter, it multiplies it to get feet, all right? And then what we want to do is let's try, let's do this. The end key doesn't work. Plus 12 feet. So that's going to be, you take the altimeter, you multiply it by, would it be plus or minus? trying to think. It's got to be a minus 12, I think. Let's do this instead. Actually, I don't want to screw with that. Let's do this instead. Desired altitude plus 12 feet. Let's do that. Okay, that's going to be better, I think. I think that's a safer way to do it than screwing with that formula. Yeah, I think that's going to be a lot better. Yeah, so I think that will be a better way to do it. So that's just our correction factor for having that in there. I think that will work well. And so here I could, so let me kind of walk you through this. So what it's doing is I'm putting that in, right? And so a lot of people will leave it with this system. They'll have it come in here and you'll put it in and the PID will go up to, I'll kind of show you here. So let's say, because I have grid lines, so let's say you're climbing up, say this line here is where I want to go. So you'll go up, right? And the PID will overshoot and then it corrects and it corrects and it corrects. And then finally it smooths out. Now, if you increased your p-value, it would go like this, and it would correct for a lot longer. If you had a small p-value, it would go like this, and it might never reach it. And it might never reach it. 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 It might reach it, but then it might go under. And so what this is doing is this is getting us, you know, this will peg out to a 5 or -5, so a big number. And then I limit it to, I say what my vertical speed is, and so this says, hey, you can have 5, and compares it to the vertical speed. Well, 5 meters per second is what we're talking about here. And so 5 meters per second, let's convert it, meters per second to feet per second. So that is 5 meters per second is 16 feet per second. And then you would do 16 times 60. So 16 times 60. That's 960 feet per minute. So I actually want that bigger. Let's do 1,500 feet per minute. So let's do it backwards. So do 1,500 feet per minute divided by 60 equals 25. So 25 feet per second is 7.62. So let's do that. 7.62 and 7.62. So that's going to give us 1,500 feet per minute. So that's going to just increase our climb rate. What is this? Pitch tilt. What is this? This is something interesting here that's not connected to anything. This can go there. This can actually go there. All right, so that is my manual control of my pitch. All right, and so what is this up here? This is connected pitch tilt 0. This is doing nothing. All right, so this is doing nothing, so there's no point in having it then. I think this is, yeah, that's doing nothing. I don't want it then. That was something to do with deck angle in the helicopter, so I don't really need that. All right, so that helps there, getting rid of some space, freeing up some space, getting us what we need here. All right, so I think this autopilot is working really well. Let's go through my list again. My mind forgets quite often. Let's see what else I have to do in here. Okay, fix the gyros not controlling the roll. So we have roll. Roll comes in from, where does it come in from? So that's my control of the roll. This here is, where does it come in from? The PID. So that they're setting my max roll, that's fine. Okay, so this is why it's not controlling roll. It's not controlling the roll because, all right, so it's not controlling the roll because this doesn't come on unless 900 other conditions here. Yeah. Let's test it with something. Yeah, this could be interesting. let's try something here. So, all right, so I need this and condition here. Let's go to here. Um, all right, so see, I think I figured the problem out. I don't think I need all this crap, but I'm not ready to. Yeah, I don't need all this crap, I don't think. I do, I think. Let me leave this. I'll figure this out later. Like this is just a pain. Like, see that? I definitely don't need, so I don't think I need this. It's not connected anyways. Yeah, I don't think I need any of this stuff. This can probably go like that. I'll delete it and then I'll rebuild it if I need to. That can go. So what is this doing over here? Okay, so that's going to yaw. Okay, so that's all my yaw business. That's all I really need it for. This is doing nothing. That's anti-torque, which was a helicopter thing. So that's gone now. So I don't need that. So I kind of don't want that to move then. Okay, so this is better. That's working that's where it needs to be. Okay, so that's where it needs to be. That's working. Again, I'm just trying to, dissect from a helicopter to a plane. The systems work differently. So that's fine. That's now working. Should work well. So what the issue is, and I think I figured the issue is, so right here I'm reading from my seat. I shouldn't be reading from my seat. I should be reading from the gyro. That's the issue. So I need to read in from the gyro. So I'm trying to see why. So all the gyro functions should be coming in. I'm trying to think how to fix this. Yeah, see, I don't have any of the gyro functions in there. So like all of these, like so seat, so the seat control should be going right to the gyro. Then instead of coming in and reading the seat, it should be coming in and reading the gyro. Because I can't go back out to the gyro like I did on the katydid. I know it's kind of confusing, but the way that the way the roll works in this is problematic, or not necessarily problematic, but I'll show you. So watch my pitch. The reason why the pitch is working fine, if we look at pitch, where's pitch? Pitch goes right to pitch fins. Huh? What is this doing here? Okay, so these are doing nothing. Stabilized roll goes up here. Okay, so roll is coming from here. It's going through the gyro. It's going up here. So that the roll should be the one that's working. Stabilize yaw, yaw. Stabilize up, down. Stabilize pitch. So pitch comes from the seat. And then it goes up here to where the heck is that going? Pitch goes to here, which is what? Pass through, gyro pitch. Pass through, gyro pitch, and then prop pitch. Okay, so this is the prop pitch control. That's fine. I want it where it is. Okay, so the way this should work here is where I'm sending this to the fins. So pitch fins right here. Pitch fins should come to the gyro next. So this should go here. Yeah, that should go there. And then stabilized pitch should go to here. All right. Yaw should go down to, I think that's just the seat. Yeah, yaw. Stabilized yaw should come up to the rudder. Roll should go down to the gyro. Then the roll should come up to here. And then this box should control it out. And so, which is it? Foils. Flapper-ons. Let's see where this is coming up here. So that goes up to roll. That's flap handle. That goes out to the starboard aileron. That goes out to the port aileron. Let's see what this is doing here and make sure everything's connected correctly in here. It should be. Should just be adding it. Yep. All right, so that should work. Little convoluted, but it works. Works well. If it didn't work well, I wouldn't use it. Bearing 2. I don't. Okay, that's if I need to read the bearing 2. I don't need to read it. All right, so let's see. Let's kind of look at my list here. So I added a correction factor. Fixed roll gyro, we'll see if it works. FO panel is an op. Let's check that out. And then we'll get ready to finish up here in a minute. I want to take it for one quick test flight, and then we'll be ready. So this is not connected to electricity, so hopefully that fixes that. So that should hopefully fix it. Altitude hold backlight. So we need to look at where my backlights are coming from. They're coming from up here. That's my systems. Okay, so it's going to altitude hold backlight. It's probably a paint issue then. So we want to do additive green. That was what it was. It was an additive issue. So that's fixed. Check fins moving out of the water. Okay, so that is the foils. My foils here should not be moving at all unless we're in the water. And they're moving, and so I don't want that. So let's see. I have linear speed, foils, fluid meter. Okay. Foils. All right, so I should be getting a 0 on the foils. Okay, if the linear speed is less than 0, so if the linear speed is less than 0, it's giving me a -1 on my foils. I don't know why I have that. Let me try to figure this out. So if the fluid meter is greater than 0, so if we're in the water, it's going to give me a 1. Okay, you know what that is? That is reverse. So it should be if the linear speed is less than 0 and the fluid meter is greater than 0. So I need an and in there. So that's why they were fluttering, is because we were less than 0. There we go. That fixes that. So now this will only operate if we're in the water, and then so the whole point of this is if I go backwards, I need the foils to operate backwards, or it will drag me into the water and sink me. And so this causes the foils to go backward, to reverse their pitch, so that when I'm backing up, it's the same thing with a boat. When you go in reverse, you need to change your stability system to have it go backwards so it doesn't drag you under the water. So I just forgot an and on there. That is fixed. Making good progress. The more progress I get, the more likely I can release it. I won't go into the overtemp. I'll probably do it and show it to you. Let's do one test flight. We're kind of getting on time on this, and I'm trying not to do too many build videos. I love building, and I especially like the closer I can get this stuff to done. I want to get some stuff out for the Stormy Awards. I want to make sure there's plenty of my builds on there. I also want to get it out to you guys. You know, if you've been enjoying watching the videos, I don't want, you know, to take 1,000 years for you to get. Okay, so this is still not working. Let's fix it. I don't want to take 1,000 years for me to get, you know, the videos out to you here, or to get the builds out to you. I want to be able to get them out to you so you can enjoy them. And so that's kind of my whole rationale there, is get some of these build videos done. Everybody and their brother's asking for Triton. Triton is going to be a long way away. Triton is any large ship will take you a long time to do. You know, just detailing alone. What is going on with this now? I bet I hooked nothing up. I thought I hooked everything up on there. I bet I hooked nothing up. So, yeah, somebody told me that this was backwards, and so I assumed it was connected. It's probably not connected to anything. Yeah, see, it's not connected to anything, so I don't know. Maybe it was a different build they said was backwards. But this is... Oh, you know what it was? I bet it was the Rotodyne. I bet that's what they said it was. I bet they said it was the Rotodyne, so I got to make sure this is actually backwards. All right, let me get us going here. Okay, so it's up and running now. I just didn't connect this one at all. Feet. So this is set up correctly anyways. All right, anyway. Somebody on a podcast said anyways, now I say it, and I've never said it in my life like that. Alright, let's go. Alright, release parking brake. We'll do this right this time. Alright, let's not have a crazy takeoff where I end up in the frickin' trees, man. Let's put on our gyro. Gyro should be functioning now. Not that I would want to take off with gyro usually, but I'm testing it, so that's why it's on. So prop is set. Let's go up with the up arrow. Okay. Gyro doesn't seem to be working my roll. So I have to check the gyro. It's still like, see, the gyro's on. Make sure that's actually turned the gyro on. 0, 0, 0. Okay, so see, the gyro is working when the AP master is on, it looks like. But roll certainly isn't. Oh, remember flaps was causing me problems. Okay, so the gyro was working with AP master. The gyro was not working without the AP master, so I need to fix that. So let me fix that. So gyro not working with gyro button, just with AP master. Only with... Yeah, I definitely recommend making a list like on a drive or on another monitor or something, because it really helps you remember, because like by the time I get done testing something, see, like I still have trims all in here. By the time you get done testing 28 things, you often forget what you're doing, and so that is kind of problematic at times. So I shouldn't be trimming this. I should be, let me put in an altitude here. Let's do 1,000. Try before I hit the water. Let's go ahead and go to a heading of 090. All right. So all our systems are working really well. The hold is beautiful. That's really convenient for when we want to go to a certain area, and or if, like I said, if I want to go AFK, I can go AFK. So to kind of talk to you about the delta heating, again, like I was saying, is I know that anything 800 RPM or less, I'm not going to overheat. And so one easy way to do that is you essentially clamp your throttle out at 800, or the PID going to your engine throttle at 800 RPM, or whatever that is in RPS, and so that it just says, hey, this is all the power you can have. The issue is, you know, as you cool, it never goes back up. Well, if you can do it by delta, the delta will tell you, hey, you're a little bit warming, so it says, okay, I'll take off a little bit of throttle. And then it says, okay, you're a little bit cooling, and it says, okay, I'll add a little bit of throttle. And it can stabilize it with a PID and put it on the perfect RPM to maintain 0 temperature rise. And so essentially, you would have that system click on, and at over 100 degrees, it would click on, and it would automatically do that. So now we are... Ugh, I did a correction in there, and it's better, but it's still not perfect. I'm not really worried about it. We're 9 feet over. That's not the end of the world. But this is flying awesome, and so this is going to be really good for getting places quickly and being able to put it on the autopilot. And so the main feature about autopilot, as I've talked about before, is workload reduction, especially if it's foggy, or I want to do something, or I need to go in the back and revive somebody. I can do that. So let's look at seating in here. I kind of like having this open area. It's open and it's kind of useless, but I kind of like it. I might put 2 seats here. I'm not sure. I don't think so. I kind of like this indentation here, so I really don't want to kind of screw with that. You know, I have this holds 5, 6 with this seat. I could put I don't know. I could probably put a couple more seats. I don't really need it or want it. You know, I had some missions where it's held more people, but I've just kind of had them stand in the middle. You know, isn't the end of the world either. So, yeah, I think we'll end the video there. I made a lot of progress on this. So this has an autopilot. This is getting close to release. Like, I can't think of much more I need to do. Like, I'd like to add a multifunction display. That's me, Lua, which is challenging for me, so I have to get into that. I need to fix the gyro. I'll do that off screen. These 2 gauges, I don't know what they are or going to be. So I need to figure something out with that. But yeah, this is working really well. Um, over temp protection I need to put in, but this is getting to the point where this should hopefully be able to be released. That was the last big thing that I needed to do was to put an autopilot in this. So I'm really happy with the progress of the Cormorant. Now that it's a little bit more in a finished state, I can use it a little bit more in career, and that'll be more fun. So if you liked the video, please give it a like, and if you enjoy my content and you have yet to subscribe, please consider subscribing, and I'll see you in the next one.